Doing a little quick video here. Today is the 29th, and I thought it would be fitting that this would be the appropriate video today. So following the same logic as I used from my last video, this one is half of an octagon and half of a decagon to give me a 9-sided geometrical shape. And once again, you know, what number do you get between 8 and a 10? Naturally a 9, right? So that's what you get when you take two of those 9-sided shapes that come from half of an octagon and half of a decagon. And I connected a line from that point to that point, and then following these segments here, right? Each side here is a segment. That segment there, and using that line, that horizontal, and that point there to that point, in there I found a 40-degree angle, which is the angle of 9. 9 times 40 degrees is 360 degrees. And same for the other side there. From that point to that point to that point, in there, 40 degrees. And so I found two Nonagons. And so that was the this kind of logic where you use a half of one polygon and a half of another polygon, spaced by 2s, so that the one in between, and you can find that one, the in between the 8 and the 10, and then I found the 9. This kind of logic here, like it, I don't think this will work for all of them, but so far I found that it worked between the hexagon and half of a decagon. Was it? No, half of a hexagon and half of an octagon to find the angle of 7. And with this one here, half of an octagon and half of a decagon to find the angle of 9, the in-between number for the nonagon. And I'm going to pause here for a second because somebody asked me a question on my last video, and I'm going to answer that. Right, so going back to the one from yesterday, or was it the day before? I can't remember now, but this was my last one before today's. He was saying, is this a heptagon? Well, no, because all sides are not equal, right? But they do come from 2 polygons. So it's a half of a true polygon and the half of another true polygon. And it was an experiment, like I didn't know. I was just, but this is what I ended up finding, right? And so when I took two of them and and overlap them so that they go through each of the middle of the other one, what I ended up finding is that I did have the angle of 7 here. So I could have completed this now. Now that I have that part, right, I can get the rest. So I could have had a heptagon there, and I could have had a heptagon there. But as I was saying for Mr. Stavros there, that, oh, geez, I think he changed his name. I think he's Woodcutter now. I can't remember. But I ran out of room here, so I didn't do it because I would have liked to have gone to there, and to get a heptagon there and a heptagon there. But I mean, I could have done two small ones here. But you get the point. But it did give me the angle that I was looking for. The two sevens, 7 in the 360 and 7 in the 360. So you can get to proper polygons out of these. They're shapes, right? They're not true polygons, even though half of them come from a true. The two halves, they do come from true polygons. I don't know. I've never seen anybody try this kind of thing. I don't know. It's just a geometrical exploration, just to see what I could find. And so, in today's, fortunately enough, I did have room, because they're just like a couple of little small ones up here, and once again, these ones, the larger ones, are not true polygons per se, but they are two halves of true polygons, Decagon and an Octagon. And it does enable me to find two Nonagons, which are proper polygons. So that's a rather lengthy explanation. Hope it's not too confusing. And that's it for today's.